Alright guys, new unit, new voice. This is Pre-Calculus Concept 7a. We're going to talk about functions. There are 5 boxes. Let's get right to it. Box number 1 is the formal definition of a limit. It states that a function is a correspondence from a first set, which is called the domain, to a second set, which is called the range, such that every element in the domain corresponds to exactly one element in the range. You're not going to be expected to know this definition word for word, but we definitely want you to understand the idea of a function. I think a good way to think about functions are just mathematical rules that take a certain input, which is your domain values, and gives you a certain output, which is your range values. So we're going to be looking at lots of functions in this chapter. Alright, the idea that every element, every input of a function has a unique output is actually a really important concept, and let's just look at these two examples below to see why that is. So on the graph on the left, if I picked a random x value, let's say x equals 2, and I ask you what the output was for that value, you would go up to the graph and give me the y value, and it looks like f of 2 would be the number 4. And no matter what value I picked, you hopefully would see that there is only one output for any given input. If I look at the graph on the right and do the same thing, for x equals 2, if I look at the outputs, there's actually 3 possibilities. And that's a problem because, again, a function can only have one output for every given input. So a quick way to test whether a graph is a function or not is what's called the vertical line test, and it states that if there are no vertical lines that cross the graph twice, no matter where you go, then the graph's a function. But if I can draw one line, vertical line, that crosses the graph more than once, then I have found a graph that is not a function. Alright, let's try a you try with that concept. So there's 4 graphs here. I want you to tell me which one is not a function using the vertical line test. Alright, hopefully you thought about each of these pictures and either in your head or on paper drew a vertical line at a couple different places, and they all passed the vertical line test except for letter C. So a circle is an example of a graph that is not a function. Alright, another thing that you're going to hear commonly with functions is the idea of domain and range. Again, I think a good way to think about domain is the set of inputs, and a good way to think about the range is the set of outputs. When you are asked to find the domain and range of a function, it's very helpful to have the graph in front of you. But basically you need to think about all the possible inputs and if there are any exceptions. So let's look at the first one here. When I'm plugging a input into the function x squared, you have to think about whether negative numbers would work, whether positive numbers would work, whether 0 would work, whether fractions would work, and consider all possibilities. It turns out that for this function, anything would work. So we usually represent that domain in what's called interval notation. If you're not sure about interval notation, be sure to ask about that in class. Alright, if I ask for the range of this function, I'm now thinking about all of the answers or the outputs that I get. And x squared is kind of special in that you would never get a negative answer. You could get 0, and so we say that our range is everything from 0 to infinity, and I put a bracket there to indicate that 0 is included. If I look at this problem graphically, what I'm really looking at for the domain question is all the x values that the graph has. And it's pretty clear that since the graph continues, that I could go forever to the right, forever to the left, and I would always have a graph associated with my x values. When you think about the range, you're thinking about the outputs, the y's, and it's pretty clear that the y answers that you would get here are only above and equal to 0. Alright, let's look at the second one. It's a little trickier. If I look at the formula here, a lot of you would immediately think about something, which is the fact that you can't take the square root of a negative number, and you're absolutely right. However, If your input was negative to begin with, then the function would make it negative before the square root applied, which means that there is a domain for this one, and it's all negative numbers. So I would write it like this to indicate any negative number is actually going to work in this function. If I think about the answers to this function, the square root will always yield either 0 or some positive number, and so the range is everything from 0 to infinity. Alright, if I look at the graph, the domain and range are pretty obvious. The domain is going to be all the x values that the graph has, and so hopefully you can see that that is all of these values. And then the range is going to be all the y values that the graph has, which is going to be all of these values. Alright, so we'll do some practice in class, but you should be able to look at a function or its graph and state the domain and range. Let's finish up with a u-try. Here is the regular square root function. I would like you to write a short answer, a multiple choice question of which domain best fits, domain and range fit the function f of x equals the square root of x. Okay, hopefully you picked the correct domain and range. Whether I'm looking at the rule itself or the graph of the rule, it should be pretty clear that the only inputs that are going to work for this function are numbers that are greater than or equal to 0, and I express that with that notation. And the only answers that I'm going to get are also going to be numbers that are greater than or equal to 0. So for this one, the domain and the range both look the same.